Okay, take a look at the moon for a second. Or, well, imagine looking at it. Specifically, its south pole.
Mm,
There's something strange hidden down there, apparently. Something so vast and mysterious, it's left even the scientists who found it kind of scrambling for explanations.
yeah, that's right. This region is genuinely one of the least understood places in our entire solar system, even though it's right there, orbiting us.
And that's exactly what we're diving into today. We've pulled together some really fascinating source material for this deep dive.
The good stuff.
Yeah, everything from data NASA missions like Grail collected to recent research out of Baylor University in Texas,
Yeah.
and also, crucially, insights into the missions now being planned to actually go back there.
Right, the upcoming ones.
Exactly. So our mission here is to unpack all of this, the strange discoveries themselves, why this specific area is suddenly seen as, well, incredibly valuable, and what this might mean for our future relationship with the moon.
Mm.
I'm really curious about what's actually hidden beneath that surface.
And what the sources suggest, it really goes way beyond just interesting rocks and craters. I mean, it has pretty significant implications for potential resources and, well, even brewing geopolitics. It's quite a story unfolding just, a 250,000 miles away.
Okay, so where did this deep dive really kick off? It sounds like the first major clue about the South Pole's secrets came from NASA's Grail mission back in, what, 2011?
That's right, GA-RAIL, that stands for Gravity Recovery and Interior Laboratory. It was designed to do something quite specific, create an incredibly precise map of the moon's gravitational pull.
Okay, and why is mapping gravity so useful for looking, under the surface?
Well, think of it like an MRI scan for worlds, sort of. Gravity mapping acts as this kind of magic window, almost, into the physical makeup of a planet or moon.
Okay,
Tiny variations in gravity can tell you a lot about the density of the material below. Whether you've got heavier elements versus lighter ones, or even estimate how thick the crust is.
like that analogy I saw about burying the Eiffel Tower in a sandbox.
Mm.
A gravity map would spot it straight away.
Exactly. That's a great way to put it. More mass in one spot means a stronger pull, whether that's a mountain you can see or something really dense buried deep underground, or in this case, under the moon's surface.
Right. And using this kind of data, back in 2019, a team at Baylor University noticed something. Well, really unexpected. Something the sources vividly call a really, really bloody big anomaly.
Yes. That phrasing stuck out. And this anomaly was located right within the South Pole Aitken Basin.
Which is already a huge feature itself, isn't it?
Oh, absolutely staggering. It's this gigantic impact crater, probably the biggest confirmed one in the whole solar system, about 1,600 miles across, over 5 miles deep. Yeah,
Wow.
roughly the depth of Mount Everest, but, going down. Formed billions of years ago by just a truly massive impact. We've known about the crater, the basin itself, for a long time.
But the surprise wasn't the crater, it was what they detected beneath it.
Precisely. The GRAIL data showed this huge solid lump of what seems to be metal buried deep under the basin. Yeah, and its sheer size is causing a noticeable distortion in the moon's gravity right there. The data suggests a mass, get this, 5 times larger than Hawaii's Big Island.
5 times the big island.
Yeah.
Buried underground.
Yeah.
On the moon, that scale is just hard to wrap your head around.
It really is. And a mass of solid metal that big, it's highly unlikely to be something that just formed naturally when the moon did.
So what's the theory then?
Well, the prevailing theory, based on the density the gravity data suggests, is that this is essentially an asteroid graveyard. Specifically, the metal core of the enormous asteroid that created the South Pole Aitken Basin in the first place.
So the impactor itself.
Right. It would have punched way down, burying its dense core deep below the surface of the crater it carved out. And really, gravity mapping was the only way we could have possibly found this thing, hidden away like that.
Wow. Okay, so a potentially buried asteroid core miles under the surface. That's one incredible secret the South Pole Aitken Basin was hiding. And you mentioned within this massive basin, there are other features, smaller craters.
Yes, exactly. And these smaller craters, nestled inside the big one, are particularly interesting. They're not only among the largest and oldest individual craters we see on the moon, but they are also, and this is crucial, the darkest.
What makes them so dark? Is it just the rock type?
No, it's actually all about the light. Or the lack of it. See, the moon's axis isn't tilted much relative to the sun. So at the poles, sunlight hits the surface at a really, really shallow angle.
Okay.
This means very little average light across the lunar day. Any areas that do get direct sunlight only get it for maybe brief periods, hours, or minutes. And for the deepest craters, the sun's rays just never reach the bottom. Ever.
So there are places that have literally never seen sunlight.
That's exactly right. They're called permanently shadowed regions. If you watch a simulation of sunlight on the South Pole over time, you see these deep spots stay completely black. Perpetually. They haven't had direct sunlight in billions of years, basically, since they formed.
That's wild. Especially when you contrast it with nearby spots, right? These peaks of eternal light.
Exactly. Often on the crater rims, you get these areas that are bathed in sunlight for maybe 90% of the time. Perfect for solar panels, as we'll see.
Wow.
But yeah, that contrast is key. Total darkness right next to near constant light.
Permanently shadowed.
Yeah.
Places in total darkness for billions of years. Right there. It's just a fascinating environment to think about.
The conditions inside these shadowed areas are incredibly stable and, well, unbelievably cold.
And hidden in these dark, freezing spots is another secret. Maybe even more important than the buried metal. Water.
Precisely. Water ice. The moon's been constantly bombarded by asteroids and comets over billions of years, right?
Certainly.
And many of these impactors, especially comets and certain asteroids, contain water. Sources estimate maybe 20% of the mass in the main asteroid belt is H2O, usually as ice.
But wouldn't an impact just vaporize all that water instantly? The heat and force must be immense.
Almost all of it, yes. You're absolutely right. The energy is tremendous. Most water just flashes into vapor upon impact. Modeling suggests something like 97% is lost immediately, either vaporized or just blasted straight back out into space. What tiny bit is left gets spread thinly or driven into the regolith.
So how does any of it survive to form, like, reservoirs of ice?
Well, a very, very small fraction of that water vapor enters the moon's incredibly thin atmosphere, its exosphere. If a water molecule happens to avoid getting zapped by sunlight, it can actually drift around.
And find its way into one of these dark spots.
Exactly. It drifts into a permanently shadowed crater. And there, the extreme cold acts like a cold trap.
And how cold are we talking? You said very, very cold.
Incredibly cold. Temperatures inside these shadowed craters can plummet to minus 240 degrees Celsius. That's minus 400 Fahrenheit.
Colder than Pluto.
Colder than the surface of Pluto, yeah.
Wow.
This deep freeze locks the water vapor down as solid ice, protects it from the sun, and lets it slowly, slowly accumulate over billions of years of impacts.
And we know this isn't just theory, right? We've actually found evidence.
Oh yeah, concrete evidence. Back in 2009, NASA had the El-Saras mission. They deliberately slammed a spent rocket stage into Cabeus Crater, a permanently shadowed one near the South Pole.
Right, I remember that. To kick up dust.
Exactly. They flew a second spacecraft through the plume of material kicked up by the impact, analyzing what was in it. And they confirmed about 5% of the mass ejected was H2O, water. That was pretty definitive proof of significant water ice hiding in these cold traps.
Wow. It still feels weird to think of ice, actual water ice, on the moon.
It does seem counterintuitive, doesn't it? But the mechanism makes sense. Delivery by icy impactors over eons, and then capture and preservation within these unique, perpetually freezing, shadowed environments.
Okay, so armed with this knowledge, this weird buried metal thing, and especially these confirmed significant reservoirs of water ice in the dark craters at the South Pole, it's maybe not surprising that suddenly everyone wants to go back.
Definitely seems that way.
NASA's Artemis program is aiming to put humans back on the moon for the first time since, 1972? Artemis 3 is currently targeting mid-2027, specifically heading for the South Pole to set up a research base.
A permanent one, potentially?
Right. And China's not sitting still either. They're planning a permanent lunar base, too, apparently in partnership with Russia, aiming for 2030. They're launching their Chain 7 mission in 2026 to actually drill for ice samples in these deep craters.
So a lot of activity focused right there.
Which inevitably brings up that, tantalizing question. Could they find life there? You always hear that phrase, where there is water, there is life.
Yes, that old saying. It's catchy, but not always scientifically accurate, especially when you're talking about extreme environments. Well, while water is absolutely essential for all life as we know it, even super tough creatures like tardigrades need it. Just having water doesn't automatically guarantee life. Think about, say, highly acidic lakes on Earth, or those super hot hydrothermal vents deep in the ocean, or even just, a bottle of distilled water in a sterile lab. You've got water, but no life.
And the moon's south pole sounds about as extreme as you can get.
It truly is. You've got almost no atmosphere. It's practically a vacuum. In the sunlit areas, surface temperatures swing like crazy, from a scorching 121 Celsius during the day down to minus 130 C at night.
Freezing.
And then, as we said, inside those shadowed craters, minus 240 Celsius, that's astonishingly cold, colder than Pluto's surface.
And then there's a radiation issue.
Exactly.
Yeah.
Big issue. No real atmosphere, no global magnetic field like Earth's. So the surface gets constantly blasted by DNA-shredding levels of cosmic rays from the sun and deep space.
Do the shadows offer any protection?
A bit, yes. The permanently shadowed regions get shielded from direct solar radiation, which helps. They might get about 30% less radiation overall than sunlit areas, but they still get hit periodically by high-energy galactic cosmic rays coming from outside our solar system.
So even if something could survive the cold and the vacuum, the radiation would get it.
Long-term survival for anything like life as we know it seems incredibly unlikely. Sources bring up examples like certain fungi found inside nuclear reactors on Earth.
Wow.
Yeah, but they survive because they're metabolically active. They can constantly repair the cellular damage that radiation causes. But if you took that same fungus and put it in a lunar cold trap at minus 240 C, it would freeze solid, go dormant.
So it couldn't repair itself.
Exactly. It wouldn't be able to perform those crucial repairs. Over time, the radiation damage would just accumulate and eventually be lethal. It'd basically be living on borrowed time, frozen and helpless.
So the scientific consensus is pretty much no chance.
Based on everything we know about the conditions, the chances of finding life that actually originated and sustained itself on the moon are considered vanishingly small, near zero. If we did find any organic material, the most likely explanation would be, contamination from Earth spacecraft, or maybe very recent arrivals on asteroid debris. And whatever it was, it would be dying or dead in that incredibly harsh environment. The water's there, yes, but the combination of vacuum, extreme temperatures, and radiation just makes it fundamentally hostile to life.
Okay, so finding life, despite the water, seems pretty much off the table given those conditions. So if that's not the main reason, what is driving this intense interest, this sudden rush by the U.S. and the China-Russia partnership to set up permanent bases specifically in that South Pole region?
Well, according to the sources we looked at, the primary driver seems to be the potential for setting up a self-sustaining lunar colony, and crucially, doing it with technology we pretty much have today.
Self-sustaining, meaning what exactly? What do you need?
You need to be able to source or produce the essentials locally. Think food, water, oxygen, and power. Constantly shipping all that stuff from Earth over 250,000 miles. It's just not financially or logistically viable for a long-term permanent presence. You need to live off the land, so to speak.
And the South Pole offers those things.
That's where its unique geography really comes into play. For power, you've got those peaks of eternal light. We talked about areas on crater rims getting sunlight almost constantly, maybe 90% of the time.
Perfect for solar farms.
Absolutely. Continuous energy for life support, communications, operations, everything. And then critically, right next door to these sunny power spots, you have the dark, cold traps packed with those huge reservoirs of water ice, billions of metric tons estimated.
So it's that specific combination, the near constant power right beside the massive water supply.
Exactly. That geographical pairing makes the South Pole incredibly valuable real estate, prime location. And the water ice, well, it's not just for the astronauts to drink, although obviously that's vital. More importantly, you can use electrolysis, zap it with electricity from those solar panels to split the H2O into pure oxygen for breathing.
And hydrogen.
And hydrogen, which is a potent rocket fuel.
So a colony could literally make its own air and its own fuel using local resources.
Precisely. It would allow a base to genuinely live off the land, slashing the dependence on hugely expensive resupply missions from Earth. But even that incredible capability, as significant as it is, might not be the absolute biggest driver.
Seriously, what's bigger than being self-sufficient on the moon?
Money. Plain and simple. Access to what some are calling a potential multi-trillion-dollar lunar economy.
A trillion-dollar economy on the moon based on what?
It mostly centers on a rare isotope called helium-3.
Helium-3, I've heard of that. Fusion fuel, right?
Exactly. It's being talked up as a potential clean and powerful fuel source for future commercial fusion energy reactors back here on Earth. The thing is, it's incredibly rare on our planet because our atmosphere and magnetic field block the solar wind that deposits it.
But the moon doesn't have that protection.
Right. So helium-3, carried by the solar wind for billions of years, has embedded itself in the moon's regolith, that top layer of loose rock and dust. It's apparently found abundantly there, relatively speaking.
Okay, so rare here, common there, and potentially a game changer for future energy. How valuable are we talking?
The numbers thrown around are astronomical. Sources suggest just 1 ton of helium-3 could potentially generate about 10 gigawatt years of energy. And the estimated value, somewhere between $3 to $5 billion per ton.
Billion, with a B.
Yep. Or look at it this way. A single gram might be worth up to $1,500 based on current projections. And the total estimated value of all the accessible helium-3 thought to be on the moon, somewhere in the ballpark of $4 trillion.
4 trillion.
Yeah.
Sitting on the moon. Okay, suddenly the rush to plant flags makes a whole lot more sense.
It really puts the current efforts into a different light, doesn't it? While scientific discovery is definitely part of it, and a valuable outcome, the sources strongly suggest that accessing and potentially controlling these resources certainly ain't the primary motivation. This is shaping up fast into a highly competitive, high-stakes space race.
And it's not just speculation. NASA's own administrator, Bill Nelson, has been pretty blunt about it. He said, "It's a fact we're in a space race."
He has. And he's clearly identified the main competitor as China, which is often working closely with Russia on their lunar plans. He's even voiced concerns about China potentially setting up shop under the guise of scientific research and then basically trying to claim territory, saying, keep out, we're here, this is ours now.
Creating a real potential for conflict over territory and resources.
The potential for friction is definitely there, and it's very real because both the U.S., with Artemis, and the China-Russia group are explicitly targeting the exact same region, the South Pole, for their first permanent bases.
Because that's where the good stuff is. The power and the water.
Exactly. You risk this scenario where nations are literally racing to stake claims on the most valuable spots, the areas with the best access to constant sunlight for power, right next to the richest deposits of water ice. And while, there's the 1967 Outer Space Treaty from the UN saying celestial bodies belong to all mankind.
Hold up.
Well, the sources suggest that treaty might not mean much in practice when powerful nations actually establish a physical presence, especially when potentially trillions of dollars in resources are involved. The fear expressed is that this new frontier could turn into something ugly, like another South China Sea situation, or even, as one source put it, literal Star Wars, driven by fierce competition for resources and strategic dominance.
It's truly incredible to think that this seemingly desolate, cold, dark region holds such immense potential economic and strategic value. The helium-3, the water for self-sufficiency, and that this is now the focus of such an intense geopolitical race.
Resource races have driven so much of human history and conflict here on Earth, haven't they? Now that we actually have the technology to reach out and start utilizing resources beyond our planet, that same fundamental dynamic, that tension between exploration, science, and national or economic interests, is just extending itself to the moon.
So just to wrap this up then, the moon's south pole, it's clearly way more complex, way more significant than we might have ever thought.
Absolutely. It's geologically unique, holding secrets like that massive buried metal chunk from an ancient asteroid impact.
Yeah.
And critically, harboring these vast reservoirs of water ice preserved for billions of years in those permanently shadowed craters.
And the intense focus now, the rush to build bases there, it isn't really about finding little green men or even just pure science. It's driven by the very practical potential for building self-sustaining colonies.
Right. Colonies made possible by that almost perfect combination of near-constant solar power on the peaks and abundant water ice nearby for oxygen and rocket fuel.
And layered underneath all that is the sheer, mind-boggling potential value of helium-3 for future energy. That multi-trillion-dollar prize, making this specific patch of lunar real estate maybe the most valuable spot off-world right now. And all these factors together are what's directly fueling this new, highly competitive space race. We're seeing major global powers vying for strategic position and economic advantage in the same limited, resource-rich areas on the moon. It's not just abstract space stuff anymore, is it? This touches on the future of energy, international relations, maybe the whole path of human expansion beyond Earth.
Yeah, we've looked up at the moon for thousands of years, right? Thinking about its beauty, its mystery.
But could this escalating drive for its resources actually mean that, one day there's going to be a serious conflict, maybe even a war over that bloody thing?
Yeah.
Leaves you thinking.